Good morning. In this unit we are going to talk about linear equations. We are going to see what a linear equation with several unknowns is. We are going to define what equivalent equations are. And for that you need to know equations with one unknown, know how to solve this type of equations, to be able to apply it to equations with several unknowns. So the first thing to remember is that an equation with one unknown is an equality of the type 5x plus 3 equals 4, where finding the solution is looking for a value of x. In this case, the value is 1/5, so that when you substitute the 1/5 in the equation, as you can see, it is an identity. That is what is known as solving the equation. That happens with linear equations of one unknown, like the one we have seen, but also with nonlinear equations, like this quadratic equation you have here, x squared plus x minus 2 equals 0, which in this case has two solutions, x equals 1 and x equals minus 2. You can see that the equation is an identity for those values. Also with the 2-square equation, x raised to 4 minus 7, x squared plus 2 equals 0, which in this case has four solutions, x equals 2, x equals minus 2, x equals root of 3, and x equals minus root of 3. And as we see, there are equations with a single solution, like the first one we have put, others with many solutions. It could even have infinite solutions, as could be the transcendent equation sin of x equal to 0, which you know has values x equal to 0, x equal to pi, x equal to 2 pi, etc., etc. And others that have no solution. So solving an equation is to find all the solutions of the equation or determine that it has no solution. When we move to equations with several unknowns, what happens is that we usually have more than one solution. Because, for example, the equation 2x minus y equals 3, as you can see, has infinite solutions. For each value of x, I will have a different value of y for x equal to 1. Substituting in the equation, we see that I need a value of y equal to minus 1 to be equal to 3. For x equal to 2, the y has to be worth 1. For x equal to minus 1, the y has to be worth minus 5, etc., etc. There are always pairs of numbers associated with each other so that they fulfill the equation, and the equation becomes an identity. In fact, in this case, this equation has so many solutions because if geometrically it is representing the line that you see on the screen, then all the points on the line would be solutions of the equation and would satisfy the equation identically. We also have, this is a linear equation, as we will see later in the definition, but there are also non-linear equations, for example, x squared plus y squared equals 4, which effectively also has infinite solutions, all these that you see there on the screen, because it is representing a circle geometrically, that is, all the points on the circle would fulfill the equation, so they are solutions of the equation. Well, we can construct as many equations as we want. These two were of 2 variables. We can also construct equations of 3 variables, as for example the equation 2x minus y minus z equals 1, which geometrically is representing a plane, and therefore all the points of the plane would be a solution. There you have, for example, 3 points that satisfy the equation. They can also be nonlinear, such as x squared plus y squared plus z squared equals 9, which also has infinitely many solutions, since it is geometrically representing a sphere. Then all the points of the sphere would be solutions. For example, x equals 1, y equals 1, and z equals the root of 7, among others. Well, in general, here we are going to be concerned with equations with several linear unknowns. So, the first thing is, what is a linear equation? We call a linear equation with n unknowns, which we will call x1, x2, xn. Any equality of this style, a1x1 plus a2x2 plus a3x3, etc., etc., up to a and xn equals b, where a sub I, a1, a2, an, are the coefficients of the unknowns. One of them must be different from 0 for there to be a solution, and b is usually called the independent term of the equation. All these numbers, the coefficients and the independent term, are known real numbers, and the unknowns are x1, x2, xn. As you can see, it is a linear equation, because x1, x2, xn, that is the unknowns, do not appear neither raised in any power, nor multiplied among themselves, nor as arguments of transcendent functions, as could be the sine, the Neperian logarithm, the logarithm in any other base, and so on. That is why it is called a linear equation. For example, the ones we have seen, 2x minus 3, I equals 7, 3x minus 2, I plus ct equals 9, and so on and so forth, adding as many variables as necessary in each type of equation. So, what shall we call the solution of the equation? Well, any set of real numbers, alpha 1, alpha 2, alpha n, that satisfy the equation. As you can see, they are associated for an alpha 1, they will have an alpha 2, an alpha 3, an alpha n, so that this set must satisfy the equation, and the equation must be an identity when substituting these numbers for the unknowns. In that case, solving an equation, as we have said, is going to be the same. That is, finding all its solutions or determining that it has no solution. So, for example, as we have seen that in some cases we had infinite solutions, and in others we had only one solution, we can talk about the general solution. The general solution of a linear equation is going to be the set of all the solutions of the equation, while each of the solutions that we can find is a particular solution. That is, the general solution includes all the particular solutions, and the particular solutions only one of them. So, for example, for the equation 2x minus 3n equal to 7, notice that I can, for each value of x, for example, for x equal to 5, so if I substitute the equation, I would have 7 minus 3 equals 7. I determine that the y has to be worth 1. That would be a particular solution. As you see, x equals 5 and equals 1. For x equal to 1, then I would determine the solution y equal to minus 5/3. In general, if I say that x is any real number, alpha any real number, then by substituting the equation, I determine that the y cannot be any but has to have this expression. 2 alpha minus 7 equals 3. That is what is called the general solution, because by giving different values to alpha, I get different particular solutions. Then, the general solution in this case depends on a parameter alpha, which is a real number. This is for an equation with two variables, with two unknowns. If we talk about an equation with three unknowns, it is exactly the same. I can construct as many particular solutions as I want. If x is 1 and y is 0, then z must necessarily be 6. As you can see, here is a particular solution. If x is 0 and y is 1, then z must be 11. In this case, for the equation to be satisfied, two of the parameters are free. Therefore, when we construct the general solution, we say if x is alpha and y is beta, any two real numbers, then z, clearing from the equation, is completely determined and must be 9 minus 3 alpha plus 2 beta. In this case, the general solution has 2 degrees of freedom. Well, we would continue. The more variables we add to a linear equation, the more degrees of freedom we have. In this case, there are 4 unknowns, so we have 3 degrees of freedom, alpha, beta, and gamma. In this case, we have given it to the last variables, c equal to alpha, z equal to beta, and equal to gamma. And so x is completely determined. And giving values to these parameters, to these degrees of freedom, we obtain each of the particular solutions. You can try to solve these equations yourselves and calculate both the general solution and the particular solutions. To do this, as you have seen, what we are doing is giving values or a parameter to one of the variables, and the other one or the following ones are determined from them by clearing. That concept of clearing is what we call passing to equivalent equations. In fact, two equations are said to be equivalent when they have exactly the same solutions, and that is what we use to solve them. The concept of clearing is to transform an equation into an equivalent equation that gives me the value of one of the variables. To move to equivalent equations, what we have to do are equivalence transformations. Among them we have, for example, adding the same number or the same linear expression to the two members of the linear equation. For example, x plus 2y equals 6 would be equivalent to x plus 2y equals 6 plus 5y. Since I am adding the expression 5y on one side of the equation as well as the other, it would also be equivalent to the equation x plus 2 and minus 6 equals 0, since I would be subtracting minus 6 in both terms of the equation. Then, whenever I do an addition or a subtraction of the same expression on both sides of the equation, I have an equivalence transformation, an equivalent equation. We can also get equivalent equations by multiplying by the same non-zero number the two members of the linear equation. For example, the same equation would be equivalent to 2x plus 4y equals 12, since I have multiplied by 2. The entire equation on both sides of the equality or divide by 2. In either case, in this way, we also get equivalent equations. The equivalence transformations are the ones we use to solve linear equations because they allow us to clear some variables in function of the others. Well, with this, as we have seen what a linear equation is, what it means to be a linear equation, how we would solve it using equivalence transformations to go to equivalent equations.